Thank you for watching this quick start on the Modelithics CLR library for Sonnet suites. This video will give you an introduction to the Modelithics library and an overview of the many model features. To tell you a little about Modelithics, we provide the most comprehensive simulation model library for RF microwave and millimeter wave devices. These models provide measurement-based accuracy and unique scalability features, and integrate seamlessly into multiple popular EDA tools. We also offer precision, high-frequency device characterization and custom modeling services. The Modelithics models for Sonnet are packaged into a convenient library, the CLR library, with models for capacitor, inductor, and resistor families from many popular vendors. These models are called microwave global models, meaning they represent a full range of component part values within a single model. The vendors shown on this slide represent a handful of the many popular vendors whose parts are represented in the Modelithics CLR library. Modelithics models are not the same as ideal component or S-parameter models. They are measurement-based equivalent circuit models for commercial parts from the most popular component vendors. The models simulate parasitic effects and offer advanced scaling capability of parameters such as substrate properties and part value. Every Modelithics model has an associated datasheet with detailed information about the features and validations. All models are developed using a consistent process and are engineered for highest accuracy. Let us show you how the Modelithics library can help you quickly reach your design goals. We will assume that you have the Modelithics library installed and the license correctly set up. So let's start Sonnet and begin with loading the models into your geometry. Once the Modelithics CLR library for Sonnet has been installed, models can be placed in a Sonnet project through the Tools, Add Component, User Model selection. Then click Browse, and you'll now see the list of Modelithics models. You can look by part type or by vendor, and it will give you a detailed description of what is contained in each model. Also notice you can click on the documentation button and it will pull up the Modelithics datasheet for that particular model. You can find useful information about the validation ranges and features of the model by looking at the datasheet. Modelithics models that are already in a Sonnet geometry can be modified by double-clicking on the part and click on Parameters. Here you can adjust the capacitance, set the simulation mode, and adjust the pad sizes. The simulation mode is very important consideration in Sonnet. We recommend reading App Note 56, which gives detailed information on simulation mode settings and port setup in Sonnet. Here is a brief demonstration showing Modelithics models in Sonnet using the example project from Modelithics App Note 56.
Modelithics Application Note 56 covers how to use Modelithics models within Sonnet suites. Starting with the pre-built Sonnet geometry, this application note covers how to view the Modelithics CLR library, how to place Modelithics components into the geometry, and how to configure these components. Also covered is a brief discussion on using the sim mode parameter to deal with pad parasitic effects. An example of an 800 MHz bandpass filter is also covered, including model-to-measured agreement. Here are two versions of the 800 MHz bandpass filter shown in the application note. The version on the left shows the models simulated in Sim Mode 0. Sim Mode 0 means that pad effects are included as part of the Modelithics model simulation. On the right, the models are used in Sim Mode 2. This means that pad effects are de-embedded from the Modelithics model and must now be accounted for within the EMCO simulation. Both simulation setups will produce identical results, as seen in the application note. Shown here is the model-to-measurement comparison for the S-tooling response of the 800 MHz bandpass filter. An initial simulation was done using only ideal models in the filter simulation, shown with the purple trace. Notice that this trace is not only shifted in frequency, but also overpredicting filter bandwidth when compared to the measured data, shown with the blue trace. Slightly better than using ideal component models is to use vendor-s parameter files, but once again, the frequency response of the simulated filter is shifted in frequency and also overpredicting bandwidth. The best model-to-measurement agreement can be achieved using Modelithics Models, shown with the red trace.
For more assistance, many additional resources can be found on the Modelithics website. On the literature page, there are many app notes, papers, presentations, and more. When applicable, an example project associated with the paper can be downloaded as well. On the support page, you can find supported simulator details, diagnostic tools, and more. There is also a frequently asked questions area to address common inquiries. If you have any additional questions or comments, please email us at support@modelithics.com. Our goal is to help you achieve fast design success, and your feedback helps us reach that goal.